Well, good afternoon, everyone, and welcome to Fox Canyon's workshop on measurable objectives, minimum objectives, measurable objectives, minimum thresholds, sustainable yield, all development for the groundwater sustainability plans. You probably saw out front, these have been up on our website, but the maps and hydrographs of the minimum thresholds. There's one pack, it doesn't say directly on the front, but one pack is Las Posas Basin and the other is the Oxnard and Pleasant Valley Basins. So we thought it'd be helpful for folks to have that in hand. Before I turn it over to Dr. Jill Weinberger to kind of go through she'll go through and present the presentation. So while she's presenting, I think she's welcomes clarifying questions on the presentation, but afterwards we're going to have plenty of time for question and answer. Specific questions we'd like to ask you to hold till the end. Any other housekeeping that I need to?
For comments.
Oh yeah, comments. So if you have specific comments on the minimum thresholds, measurable objectives, or any of the materials, then be sure to ask them if you like, but be sure to submit them to us also in writing. There's an email address that we have on our website that's specifically for comments on the groundwater sustainability plans. That way we'll be sure to get those addressed, and we'll have a record of specific comments that you might have on specific minimum thresholds and measurable objectives. And with that, I'll turn it over to Jill.
So I haven't done a sound check with this mic. Doesn't sound, oh, there we go. Can people hear me in the back, hopefully? Good, thank you. So as Kim said, we are here today to go over really the development of the estimates of sustainable yield, to look at how those relate to the minimum thresholds that are currently proposed. I think many of you probably have seen the memos that came out that are on the website. If you haven't seen them, I think I have a link, or at least an image of the address of the website at the end, so you can go there and review the memos that have further written information, and then also tying the minimum thresholds and the sustainable yield into groundwater production. Now, of course, the way that all of this will come together is in the draft GSPs, and those will be out in a few months. But this is really to try to get feedback. I'm really looking for feedback on these. We're not here to do anything other than to give you information, and then if you've got some feedback that would help us refine that information, we really do welcome it. And so as Kim said, though, to start with, during the presentation, I'm happy to take clarifying questions. Please don't sit there confused for a slide or two. Please ask your question right up front. But if it is a broader question, a broader point, then if you could save that for the panel discussion at the end, that would be helpful. Just from the most basic background point, I don't think there's a single talk about sustainable management criteria or the Sustainable Management Act that doesn't start with the line that it was passed in 2014, feels like 1914 at this point. It passed in 2014 and acted in 2015. And in the legislation, the Fox Canyon Groundwater Management Agency was specifically named as the groundwater sustainability agency for the basins that it oversees. And primarily for our purposes tonight, we're going to be talking about the Oxnard, Pleasant Valley, and Las Posas Valley basins. These basins were, the DWR basin boundaries are shown on, I'm going to get this wrong again. Oh, here we go. The DWR basin boundaries are shown as the shaded colors in here, the green for Las Posas, purple for Oxnard, yellow for Pleasant Valley. And the boundary of the agency, you'll see, actually differs from the DWR basin boundaries, and that has to do with how the agency was formed, which is to the extent of the Fox Canyon aquifer, which is a little bit different from the surface features and other features that DWR used to define their basin boundaries here. A lot of work has been done before we got here tonight, and that work came out, some of that work came out in the form of preliminary draft GSPs that were issued in November of 2017. The board released those for public review. The intent of the preliminary draft GSPs was certainly to provide the background information that we had, certainly the hydrogeologic information on these basins, and provide stakeholders with the opportunity to comment on that information as well as on the information that was going to be going into the development of the sustainable management criteria. In the meantime, over 2017 and 2018, we continued working, and I think for those of you who were here for the earlier presentation, there was a tremendous amount of modeling work that was done over that following year to look at how groundwater production is tied into groundwater elevations and is tied into the sustainable management criteria and the sustainability indicators that we will be evaluating as part of SGMA. So there's been additional modeling analysis, and that's why we're back tonight, is to present the results of that. And a lot of that has been in the form of models. So 2 models have been prepared. One is the United Water Conservation District model. This covers West Las Posas Basin. Las Posas Valley Basin is split into 2 management areas, western and eastern. The West Las Posas Valley Basin, the Oxnard Plain, and the Pleasant Valley Basin are all in the United Model Domain. And they're all in the United Model Domain because there is a hydrologic connection between those 3 basins. And so it makes sense numerically to model those as a single model domain. Distinct from that is the East Las Posas management area, and that was modeled with using a Callegas Municipal Water District model. And these models were developed for their own purposes, but when they were applied to the Sustainable Groundwater Management Act and to developing the GSPs, there was a lot of collaboration between staff and DUDEC and the technical advisory group members and the modelers into how to develop the appropriate model scenarios that would be used in the GSPs and to help us develop the sustainable management criteria. So looking at both the regulatory side from DWR and the recommendations from TAG and others and staff, we developed 3 really critical model scenarios. This doesn't mean we only ran the model 3 times. There was a lot of work to get to refine these model scenarios. But the 3 model scenarios that I'm going to be talking about, and these apply both to the United Water Conservation District model and to the Callegas Municipal Water District model, are a future baseline scenario. The assumption in the future baseline scenario is that 2015 to 2017 production rates continue over a 50-year period into the future. That 50-year period, the need to model a 50-year period is part of the SGMA regulations. The exact parameters that go into that period, including climate, are not specified in the regulations. So DWR has provided guidance on climate change factors that can be applied to the precipitation and the hydrology that are used in these 50-year simulations, but they didn't select a 50-year period and say, hey, everybody, you across the state, you're going to model from 1950 to 2000. That's your model period. See what it looks like moving into the future. So to get to a climate period that was selected, we worked with TAG, and TAG actually selected 2 different 50-year periods in order to look at the uncertainty associated with having different climate scenarios. Because as people have said in this room and in the TAG room, picking a climate scenario is pretty much a guarantee that you're not going to have that exact series of rainfall, right, over the next 50 years. So we do our best, and we look at the uncertainty associated with that. So future baseline, 2015 to 2017 production, carried over 50 years with 50-year climate period that runs from 1930 to 1979. Then there is a development of a sustainable yield without projects scenario. Now, I will stop right here and say, if that future baseline scenario indicated that everything was sustainable, there was no need to go any further. It didn't, and we'll talk about that in more detail later on. But then we had to come to a sustainable yield without projects scenario. And so that is looking at what the pumping would be if you don't implement any additional projects in the basin in order to come to sustainability. And lastly, the sustainable yield with projects. Now, the projects that were incorporated into these model scenarios were projects that met the general criteria for being allowed to be incorporated by DWR, and were also vetted by the Fox Canyon Board Operations Committee process and through the board. They were approved by the board for use in these models. It does not mean that they've met regulatory approval or that they will have to happen. It was just the set of projects that was approved to be examined and investigated in these models. And what is it that we're investigating here? Well, what we're really doing is we're looking at the relationship between groundwater production and water levels, and we're looking at the relationship between groundwater production and undesirable results. That term, undesirable results, is one that many of you have heard a number of times. It's one you're going to hear a number of more times tonight. They are defined locally. So even though SGMA specifies sustainability indicators, the exact undesirable results are left up to local jurisdiction to define. And they're based on a concept of significant and unreasonable. What's a significant and unreasonable impact? And that ultimately is up to the FCGMA board to decide. So the goals for tonight, that's the quick background. The goals for tonight bring you up to speed on the work that's been done to develop the sustainable yield for these basins, and also how the sustainable management criteria were developed, specifically focusing on the minimum thresholds and measurable objectives, but also then tying this all together because it's all part of the same package, relating the sustainable yield to the minimum thresholds, relating it to the measurable objectives, and ultimately relating it to groundwater production, groundwater levels, things that can be reported to DWR. And of course, most importantly, is to answer questions that you may have and get your feedback on what's been presented so far. So with that, we will jump into the development of the sustainable yield. I don't think I was, development, I think I hear Peter saying estimate of the sustainable yield. I should keep that in mind for the rest of this. I don't think I shocked anyone in the room when I said that the future baseline groundwater models did not come up with sustainable conditions, and I shouldn't have shocked anybody because when we look historically, we've seen undesirable results in these basins in the past. But let's start with the SGMA definition of sustainable yield, which is not specific to any basin, it's the broad general definition. And the SGMA definition is that the sustainable yield of a groundwater basin is the amount of groundwater that can be withdrawn annually without causing undesirable results. Hopefully nobody's playing a drinking game with that term, undesirable results. It's going to show up a lot. here's what we have for the historical seawater intrusion modeled with the United Water Conservation District model. So this is historical, 1986 to 2015. We're not predicting anything. We're looking at the past here. And anytime you see a bar here that's above 0, that is seawater intrusion into the aquifer system. And so historically, if we look at the lower aquifer system here in green, every year in the past, there was seawater intrusion into the lower aquifer system. If we look at the upper aquifer system in this gold color, there were a few years in the past where we actually had freshwater flow out historically, but the dominant signal is a seawater intrusion signal. So historically, there have been undesirable results. One of them in Oxnard is seawater intrusion. There is also a concern about chronic declines in groundwater levels and the loss of storage associated with that. So moving forward, we have to simulate a future without undesirable results. And the critical thing is that even though we have developed these estimates of sustainable yield, this second bullet here, I mean, I guess the first one is equally important, that in the guidance it says Sigma does not incorporate sustainable yield estimates directly into the sustainable management criteria. And I'm trying to develop that relationship here tonight, so hopefully we're going to see how that relationship develops. But the critical thing is that basin-wide pumping, if you pump within the sustainable yield estimate, DWR does not consider it a measure of or proof of sustainability. So you cannot report your production to DWR and say, hey, we've got an estimate of our sustainable yield. We're pumping below that estimate. We're good, DWR, leave us alone. What you have to report to DWR are sustainability indicators. You have to report water levels. You have to report groundwater quality data. That's what's going to prove to DWR that the basin is being managed sustainably. So what are those sustainability indicators? These are these 6 symbols that DWR developed a long time ago. This arrow is chronic declines in groundwater levels. This is a loss of storage, subsidence, seawater intrusion, groundwater quality, and a loss of interconnected surface and groundwater. Not all of these are really critical in these basins. We know in East Las Posas we don't have seawater intrusion in the East Las Posas Basin. We know in Pleasant Valley and West Las Posas we don't have direct seawater intrusion under those basins. We do have a hydraulic connection that can influence Oxnard there, but we don't have direct seawater intrusion. So what we're going to be focusing on tonight really are the chronic declines in groundwater levels, which are associated with everything else, really, but chronic declines in groundwater level and seawater intrusion. And just as a reminder, right, here's the Oxnard Basin. If we ask this question, is the 2015 to 2017 production sustainable if continued into the future? The answer is no. I already gave that answer. And this is hopefully to clarify these plots because we're going to see these a lot. This is now moving into the future. So this is not the historical plot that I showed before. This is looking at that 50-year climate record that I was talking about, moving 50 years into the future, starting in 2020 and moving into 2069. At the 2015 to 2017 groundwater production rates, you see that there are years where these yellow bars, orange bars, are below the 0, right? That's in this gray area. The gray is linked to that gray arrow, meaning water is flowing out to the ocean. And instead, most of the years, we have in this blue shaded area, and the blue is here, that's seawater intrusion. So we're always going to see this gray and blue relationship, although I will get rid of it on the graph just for clarity. So I'll leave it off to the side there. And again, I'm splitting this between the upper aquifer system and the lower aquifer system. And furthermore, just as a reminder, because at some point I'm going to show you aquifer maps, the upper aquifer system is the Oxnard and Magoo aquifers. And the lower aquifer system is the Hueneme, the Fox Canyon, and the Grimes Canyon aquifers. So in this simulation, 2015 to 2017 production rates, seawater intrusion in the lower aquifer system every year between 2020 and 2069. It's not sustainable. Seawater intrusion in the upper aquifer system, 37 of the 50 years. Not sustainable. This allows for net landward migration of the 2015 saline impact front. And this is important because one of the board goals that was adopted in 2015 was not to allow for net landward migration of this impact front. And we're going to see in a couple of slides what that landward migration looks like, because the groundwater model is a powerful tool for helping us understand that. Before I get to that, though, not to forget about chronic declines in groundwater levels, we can do the same exercise and look at the 2015 to 2017 groundwater production rate in the East Las Posas. And in this case, you have a long-term decline in groundwater level over that 50-year model run. Now, the assumption that went into this is that the recharge to the arroyo would be decreased through time based on information that we had. So there is an assumption built into this that you would not continue to receive the same recharge into the arroyo in East Las Posas. And so with that information and the reductions that we had been told and to incorporate and had worked with TAG to incorporate, this was the long-term decline in groundwater level. Now, not to divorce groundwater level from the other sustainability indicators, we can take a look and see this is now change in storage. So there is a cumulative loss in storage from the model domain between 2015, for the 2015 to 2017 pumping rates on the order here of 160,000 acre feet, roughly 3,300 acre feet per year. So that is not a sustainable loss of storage for this basin. I'm going to focus now on seawater intrusion and how we get to estimating sustainable. And then I'm going to go and do the same thing for chronic declines in groundwater levels. So we'll start with sustainability for seawater intrusion, and I'm going to move then to sustainability for chronic declines in groundwater levels. So we have to ask the question, what is sustainable if continued into the future? That's the logical next question. That's the question DWR requires us to answer. And we were guided in answering that by these board goals that were adopted in 2015, which is, it is production that does not result in a landward migration of the 2015 extent of the saline water impact front in the Oxnard subbasin. So what does that mean? This purple line happens to be in the southern part of the Oxnard Basin. This is the Magoo area here, in the Fox Canyon aquifer. So there are different, these lines are different for the different aquifers. I am not showing you every single one. This is an example from the Fox Canyon aquifer in the Magoo area. This would be, that purple line would be the saline impact area. And we can use the model to help us understand this and how future production might influence it. We can also measure seawater intrusion, right? I mean, this is something that people do. It's something that people have known about for a while. We can measure it by looking at chloride concentrations in groundwater. And we can measure it looking at groundwater levels and what that would do to the groundwater gradient and the flux out to the ocean. TAG discussed early on which of these two indicators were better indicators for DWR and reporting to DWR and progress towards sustainability, and came to the conclusion that the groundwater level is what is known as a leading indicator, right? So groundwater levels influence flux much sooner than you would actually see the migrating path of the chloride concentration. So groundwater levels, if they're kept low for too long, you would know that that's coming. You might not see it yet, but the chloride is coming. Whereas by the time the chloride gets there, it's too late. So the groundwater levels were discussed as a leading indicator. And so what we're looking at is how are we going to relate groundwater levels to seawater intrusion over a large interconnected aquifer system? And we're in luck because we have the United Water Conservation District model to help us do that. That numerical model was calibrated to groundwater elevations. These are what we're going to be reporting. And the numerical estimates of seawater flux, groundwater production, and groundwater elevation are all developed as part of this same united model. So what we can do is look at a particle tract in the model if we start a particle of water at the saline intrusion front. And we ask the model to tell us where that particle is going to travel over the 50 years of the model. And if we do that, we've broken this out into the first 20 years in green and the last 30 years in red. And we see that under the baseline model run, just as we were seeing seawater intrusion in those bar graphs, we're also seeing a large landward migration of the seawater intrusion front. So that would tell me that that first model run doesn't work to meet the board goal of not allowing for further net migration, landward migration of the saline water impact front. Instead, as we move towards reducing production and incorporating those projects that were discussed with the board and with TAG, we can actually greatly reduce that landward migration. Again, here, the green is the first 20, and there's virtually no red in this simulation, and that's the last 30 years. That's that sustainable period, the sustaining period that I'll be talking about, because we have 20 years to get to sustainability. So the idea of modeling this 50-year period is you got your 20 years to get there, and then you've got to show DWR that you can keep it there for 30 subsequent years. And lastly, a different look. This is the reduced pumping without projects. There is a landward migration in the larger, certainly, than the one with the projects, and it's roughly equal between the 20 and the 30 years there. This is what it looks like in those bar charts that you've been seeing. This is the reduced pumping with projects. Now what we're seeing here is a big difference in the lower aquifer system in green and the upper aquifer system in yellow. So in the upper aquifer system, these reductions have effectively overshot. We're seeing a lot of groundwater moving out to the coast, which is not the intent of Sigma. It's not to send all the groundwater out there. It's just not to allow further migration inland. Whereas we didn't quite get there in the lower aquifer system. In the lower aquifer system, we're still overall on balance seeing seawater intrusion. And the same is true for that reduced pumping without project scenario. We overshot in the upper aquifer system, groundwater flow out, and we still didn't quite make it with the lower aquifer system. So I'm going to take you through what the actual simulated production for each of those scenarios is on the bar chart, and then come to our estimate of what the sustainable yield would be associated with that, with the understanding that we overshot in the upper aquifer system and didn't quite get there in the lower aquifer system. So the simulated production for the future baseline was 40,000 acre-feet a year in the upper, 29 in the lower. In the reduction with projects, it was 27 in the upper and 13 in the lower. Without, 27 in the upper and 12 in the lower. So that was a starting point, but we then actually, for those of you, again, that were here earlier, we used the multiple models that we had to develop a relationship between groundwater production and seawater flux. And because we never quite got to zero in any of the actual simulations, we had to look at this additional relationship. And so our estimated sustainable yield for the upper aquifer system is actually closer to 32,000 acre-feet a year, so it's a little higher than what we had here because we were sending water out to the ocean with a confidence interval of plus or minus 6,000 acre-feet a year. In the lower aquifer system, it's a little lower. It's 7,000 acre-feet a year, lower than these two simulated values, again, because we continued to have intrusion in the lower aquifer system with confidence interval of plus or minus 3,000 acre-feet a year, for a total of about 42,000 acre-feet a year, plus or minus 9. That's our starting estimate of the sustainable yield. But we all remember that bullet point that said we can't just report pumping, so we now have to tie the pumping to the water levels. Of course, I clearly put that in too soon as a reminder here, because that's not what's on my next slide. I'm going to go through it for Pleasant Valley and West Las Posas, and then I'm going to tie it to water levels. The sustainable yield in Pleasant Valley is, in fact, tied to Oxnard's ability to meet its sustainable yield and eliminate seawater intrusion because the basins are hydrologically connected. The connection, however, is stronger in the western part of Pleasant Valley Basin and not as strong in the eastern part. The same is true for the West Las Posas management area, where in the western part of the West Las Posas management area, there is a hydrologic connection that is factored into Oxnard and Oxnard's ability to meet its goals. In the eastern part of the West Las Posas management area, that's where we're really looking at chronic declines in water levels as our sustainability indicator. So let's look at Pleasant Valley. Here, this is that baseline scenario. It was not sustainable. 6,000 in the upper, 7,000 in the lower. The reduction with projects was 2 in the upper, 5 in the lower. Without projects, it was 3 and 5. And now we're going to also take a look at that separate estimate that we did using all of the model runs. And from that relationship, we can actually say, in Pleasant Valley, not only did we allow groundwater flux out in some of these model runs, but that in Pleasant Valley, we never quite zeroed in on what the sustainable yield was with these specific model runs. So instead, if we look at the models as a whole and we develop a relationship between groundwater production and seawater flux, we can actually come up with a sustainable yield estimate for Pleasant Valley that's closer to about 11,600 acre feet per year. So it's more than this 8,000, it's more than the 7,000 modeled here. It is less than the future baseline, and it's divided into the upper and lower by about 4,400 acre feet and 7,200 acre feet. I left the hundreds in here so you would see how the rounding would start to affect these if I dropped that out. And then for West Las Posas, using the same methods that we did for Pleasant Valley, here are the actual model runs, but again, we step back and look at what the collection of model runs tells us, and for that we come up with a sustainable yield estimate. Shallow is pretty consistent, about 1,000 acre feet a year. The lower aquifer systems, about 11,500 for a total of about 12,500. So again, that's a little larger, not much larger than this reduction without projects, but it's a little larger than the reduction with projects. So I said we were going to get to the relationship between groundwater production, groundwater elevations, and sustainable yield, and this is where we start to get there. We know that groundwater production is related to groundwater elevation. That's a simple understanding, and that seawater flux is related to groundwater elevation. And sure enough, if we look here, this is just one well, this is just an example, I'm not going to get into the details of this, but if we look at this one well, this is very similar to all of the coastal wells in the United model that we see a linear relationship, a very tight linear relationship between groundwater elevation over here and flux over here. Positive flux here is seawater intrusion. So this is seawater intrusion at these water levels. So when we're below 0, and in fact, when we're below about 10 in this well, we have seawater intrusion. When we're above about 10, just that little tip right there, we have fresh water flowing out. Water levels are really useful, though. They're easy to measure. We can get direct measurements of them. We have long-term historical records of water levels. And they can be reported to DWR as proof of sustainability. So this is really what we're relying on moving forward, and it's how we're going to begin to select these minimum thresholds. So when we look now at the 3 model runs that I've been talking about so far, we're talking about the baseline, the reduction with projects, and the reduction without projects. We look at the baseline, that future baseline model run in one well, close to the coast, southern part of Oxnard. These are the modeled water levels, simulated water levels over the 50 years moving into the future. And we'll see that those are very similar to the historical water levels shown in the black. But we know historically we had seawater intrusion. We know when we look at the 2015 to 2017 pumping rates and carry those forward, we'll have seawater intrusion. So that all works in the sense that they all make sense together, but that this is no longer sustainable in the eyes of DWR. Instead, as we reduce pumping, we see water levels recover, and they come up to higher water levels in the reduction without projects and the reduction with project scenarios. And in fact, the band around 0, plus or minus 20, is roughly our sustainable range when you look past 2040, our date when we're required to be sustainable. So here's that band of water levels that would keep this basin sustainable through this particular climate scenario moving forward. The sustainable range is higher than most of the historical measurements, and historically the basin has experienced seawater intrusion, so this is not surprising. What it does mean is that over the 20-year periods to get to sustainability, you will have water levels currently that are below a proposed minimum threshold, and that it's over a 20-year period that you will be working to bring those water levels up higher. If we relate this back to flux, this is that bar chart simplified just in the background here. We also are looking to develop the minimum threshold. So what is the lowest simulated water level from which the basin recovers so that ultimately there's no net seawater intrusion? And so now we're getting back, that's why this flux chart is here. So no net seawater intrusion, no migration between 2040 and 2070. And in this case, it's approximately minus 20 feet mean sea level. But you've heard me talk about uncertainty, and there's uncertainty in all of this. Of course, the model will give you whatever number you want to 1,000 decimal points. It's math. That's what it does. And so in this case, that low water level in that same well, I've just zoomed it in on the low point, was minus 20.03. I could give you a lot more decimal points. It doesn't mean we know it to that level of precision. That's just the level of precision that you can ask of the model. There's uncertainty associated with this. So to begin to account for uncertainty and planning purposes, we said we're going to take the low water level, whatever it is, and round it down to the 5 feet below it, the nearest 5 feet below. So even though this is minus 20.03, this gets rounded down initially to minus 25. And so that's the water level that you have seen. If you've seen the memos, that's the water level that's reported as the minimum threshold. There was a question probably 2 or 3 board meetings ago about accounting for seawater intrusion. It's a very good, sea level rise. Let me step back. There was a question about accounting for sea level rise, future sea level rise. It was a very good question, and it's not inherently built into this model. Instead, it's done after the fact. And so ultimately, when you look at the predictions for sea level rise in the area, they're on the order of 1.5 and 1.8 feet. So ultimately, again, we don't know it to that level of certainty. We will add 2 feet to the selected minimum threshold to account for sea level rise. So it would end up right about there, and in this case at minus 23 feet. These are the maps that are in the packet. I'm going to just zoom in a couple of places. These maps relate the proposed minimum thresholds, and I'm going to keep these at the rounded to 5-foot intervals stage for this, because that's what you have. It's an easy way to think about this. Zoom in on a couple of these, and these relate the proposed minimum thresholds to the 2015 water levels. So This is well 20J08. It's got a proposed minimum threshold of 5 feet. That's positive 5 feet. So we're talking roughly 15 feet, maybe 20 feet of rise from the 2015 water level that would be needed to get to the minimum threshold. You've got 20 years to get there. I'm just going to step through these, and I should have said that was for the Oxnard aquifer. I'm going to step through these. These are for each aquifer. The Magoo aquifer is in the upper aquifer system. The Oxnard aquifer was also in the upper aquifer system. Here again, we've got roughly 0 feet here, 0 feet here, 5 feet. A little farther inland, we've got 10 feet, and you're looking at a 20 to 25 foot rise in water level to get there. The Hueneme aquifer, and also well screened in multiple aquifers. In this case, Hueneme is in the lower aquifer system. In this case, you might have increases on the order of 50 feet from the 2015 water level to get to the minimum threshold. And you're going to see that fairly consistently. I'm going to zoom in a couple places in the Fox Canyon aquifer, which is in the lower aquifer system, that the water level recovery in the lower aquifer system is larger than it is in the upper aquifer system. So here we've got, in this well, the minimum threshold is set at 15. The 2015 water level contour there was minus 40. Right, so that's about a 55-foot difference between the 2015 contour and the minimum threshold. Over in the Pleasant Valley area, you've got minus 55 here. These contours, this is the minus 120. This blue line, I'm sorry that got cut off. So this is minus 140, minus 120, minus 100, minus 80, 60. This is minus 120. So again, there's quite a difference here. You've got to bring that up close to 70 feet. If we look down south in the Fox Canyon aquifer, here we have 0 feet at the coast, and the 2015 contour was at minus 40. So in the lower aquifer system, we're looking at a 40 to 60 foot, maybe 70 foot in some places, difference in the water in the minimum threshold between the 2015 water levels. In the upper aquifer system, it's closer to 20-foot difference. And last but not least, in the Grimes Canyon aquifer, also in the lower aquifer system, similar, right? This is about a 75-foot difference between the 2015 water level and the proposed minimum threshold. So those are the minimum thresholds. You've got, hopefully you have the tables. If you didn't get the memos, I think the tables, the revised tables are out front too. But there are a couple key things to keep in mind about these. First of all, they are static water levels. So they're not a pumping water level. They've got to be a recovered water level. DWR prefers that they are measured in monitoring wells so that you don't run into the problem of having a pump in the well and waiting for that to recover. They're supposed to be a measure, really, of the overall production in the basin and the overall water level in an aquifer system. They are not directly related to the production in an individual well, and they're difficult to directly relate to the water level in an individual well. Instead, they've been selected for these key wells, not in every well, just in key wells throughout the basin, and water levels in wells that are not key wells are not going to be used to assess sustainability. So if you have a well and your water level, your static water level is below the minimum threshold, but the water level in the key well next to you is at the minimum threshold, your well is not going to be used to say that the basin's not sustainable. We're looking at these key well water levels to look at sustainability. Moving then from the minimum thresholds to the measurable objective, in Oxnard and the western part of Pleasant Valley, and in one well, in the west part, one key well, in western West Las Posas, we do have to tie the measurable objective back into the minimum threshold. Because if you remember, and it will probably be burned into your brains, if you remember these charts, right, what we see is that there are water levels for which, here we've got low water levels, there is seawater intrusion. And when you've got higher water levels, here, we actually reverse the flow direction and have flux out to the ocean. And so if you only have water levels that are clustered around minus 25 or 23 feet, which is the proposed minimum threshold for this well, you will continue to have seawater intrusion, and you see that in these bars. But you're allowed to have water levels that go up and down. You are allowed to have operational flexibility. You're allowed to account for drought cycles. And so the way that we do that is to tie this to a measurable objective. And the measurable objective is pretty close to the water level, if I can pull this up. It's pretty close to the water level at which there is no net seawater intrusion. It's not quite there yet, but it's a starting point for this. And so what you would want to have is your water levels above the measurable objective 50% of the time, and during those time periods you are sending fresh water out to the coast. You're keeping the seawater at bay, but that also allows for you to have your water levels go below it 50% of the time and allows for periods of flux in from the ocean, and it allows you that operational flexibility in the basin. So in this particular example, the measurable objective was set to 0 feet mean sea level. It's the median water level here over the 30-year period during which we're looking at sustainability in the basin. So when groundwater elevations are higher than the measurable objective, seawater intrusion is less than or equal to 0 is the goal there. So now I'm going to switch from developing the minimum threshold and tying that to production for seawater intrusion. I'm going to switch to the case of chronic declines in groundwater levels. Here, just as in Oxnard with seawater intrusion, here we know that chronic declines in groundwater levels have occurred in the past. They have occurred historically. They are their own sustainability indicator, right? One of those 6 caution signs from DWR. Chronic declines in groundwater levels are their own sustainability indicator. They are also tied to change in storage. They're really tied to every other sustainability indicator as well. And DWR explicitly says that groundwater extractions and recharge should be managed, quote, to ensure that reduction in groundwater levels or storage during a period of drought are offset by increases in groundwater levels or storage during other periods. So that's what we're looking at when we're talking about chronic declines in groundwater levels. This is just an example of a historical water level in West Las Posas, in the West Las Posas management area, where there were declines in groundwater elevation through time that were offset during periods of in-lieu groundwater, resting of groundwater production, in-lieu surface water deliveries, and then declining again recently. These are examples of in the Epworth gravels in the East Las Posas management area, and also in the Fox Canyon aquifer in the East Las Posas management, showing historical declines in groundwater levels. And the board, similar to their goal for Oxnard in 2015, they adopted a goal that said that the goal was to promote water levels that would mitigate or minimize undesirable results. And this includes pumping trough depressions. These are examples of the undesirable results, right? Pumping trough depressions, surface water connectivity, and chronic lowering of groundwater levels. So how is it that we evaluate long-term trends in groundwater levels during the 50-year future simulation period, and how are we going to relate those to trends in other sustainability indicators? Well, again, just as in Oxnard, we had a numerical model. Here we've got a numerical model that can estimate the change in storage, the groundwater production, and groundwater elevation over these scenarios. This is one well in the Fox Canyon aquifer, East Las Posas, relatively close to the arroyo, where there's a tremendous amount, or there has been a recharge through time along the arroyo. It's where the majority of the recharge to the East Las Posas Basin occurs. And historically, we see back in 1970 that we had water levels down around 100 feet, mean sea level. With that recharge along the arroyo, they came up 200 feet and then have been declining somewhat since then. And then if we run the groundwater model 50 years into the future and we do a couple of different scenarios, we can see what happens. Well, here's happens to those water levels moving into the future. So here's that 50-year model run, the model run water levels in blue, and the blue here is that future baseline. So keep in mind, the key assumption in this future baseline is a reduced recharge through the arroyo, reduced surface water availability to the arroyo. So if you continue producing at the current rates and you have reduced infiltration along the arroyo, you will see groundwater level declines comparable to the increases that we're seeing historically. If instead you have introduced projects to the mix, and in the East Las Posas Basin, those projects that were incorporated into the models were really primarily focused on keeping surface water flow in the arroyo and maintaining that flow and maintaining that recharge. So if you do that and you introduce projects and, in fact, in this case, reduce pumping, you can come up with a level water level moving into the future. And there are no chronic declines. There's no loss of storage moving into the future. And we've done that for several different model scenarios, just like as in Oxnard. The baseline water production, if we continue that, it's 22,000 acre-feet a year. If we continue that into the future, even if we look close to the arroyo in this well 10J1, which was on the previous slide, this is that downward trend. And if you add in just projects, no actual pumping reductions, this is that gray line here, just projects added into that. So if you continue production into the future and you reduce recharge along the arroyo, you get the blue line. If I can pull this up again. Here we go. But if you continue production into the future and you maintain more or less today's recharge along the arroyo, you get the gray line. So there still is an overall loss of storage there. It's on the order of about 750 acre-feet per year. And now we're getting into these questions of significant and unreasonable. Over on the left, right, if we look at this well 35RO2, here's the historical water levels in this well. This is where it is in the basin, more in the central part of the basin, removed from the arroyo. This is what you would see continuing 22,000 acre-feet a year of groundwater production with the decreased recharge. This is what you would see if you continued 22,000 acre-feet a year of production, even maintaining that recharge. And so you can see this long-term decline in groundwater level, even with the maintained recharge right here. That long-term decline in groundwater level is what's beginning to account for this 750 acre-feet per year of storage loss throughout the basin. So it's not sustainable throughout the basin. You may be able to say that this looks pretty good, but if you start to investigate other wells throughout the basin, you see long-term declines there. So we developed these scenarios to look at maintaining the current status quo, maintaining the status quo with reduced recharge, and then what happens if we reduce groundwater production as well with maintaining recharge, and what happens if that recharge goes away and all we can do is reduce production. So that's what's shown in these different charts here. This 20,000 acre-feet per year yellow plot is maintaining recharge and reducing production to 20,000 acre-feet a year. And in that, we would see that this is the general breakdown of what that 20,000 acre-feet a year looks like as far as the different aquifers that it comes from. 77% of it comes from the Fox Canyon aquifer, 10 from the Grimes, 6 from the Epworth. The upper San Pedro is also at 6 and the shallow is at 1. This 17,000 acre feet per year, that's if there is reduced recharge in the arroyo, and the only thing that can be done is reduce groundwater production to get to stable groundwater levels. So this is how that breaks down, 12,700 acre feet per year from the Fox, and then the percentages for the others. And what that range of models provides us with is another estimate of the sustainable yield. So the initial estimate of the sustainable yield in the East Las Posas is about 200 acre feet per year for the shallow. It's not being used much as it is. The Epworth Gravels is about 1,300 acre feet per year. The Upper San Pedro is approximately 1,200 acre feet per year. The Fox Canyon Aquifer has a range of 13,000 to 15,000 acre feet per year, and the Grimes Canyon is 1,600, approximately 1,600 to 1,900 acre feet per year. So the total here is, depending on the projects that get implemented, we're looking at a total sustainable yield estimate of about 17,000 to 20,000 acre feet per year. If we look at the two, let me go back here for a second. I'm going to focus on these two scenarios. Again, the gold here is maintaining flow in the arroyo and reducing production somewhat, and the purple is a reduced production only. We can look at those gold and purple lines in these plots, and you'll see that it varies depending on where you are in the basin. So you can see that here there is some decline with the reduced production, but if you maintain flow in the arroyo, the water level in this well is much more stable. This is close to the arroyo, so it's not surprising. If you look farther away from the arroyo, these two scenarios are very similar. Water levels in them are very similar. And then focusing just on this one well in the Epworth Gravels, you'll notice that I went back to the green color here because we adjusted the production rates somewhat differently for the different aquifer systems, for the different aquifers, I should say, and the different model runs. So for the Epworth Gravels, this purple actually, I think, overshot our goal. So the water levels started to rise. We reduced it too much. So instead, we looked at about a 12% reduction is what we saw in the green run there, and that translates again to about that 1,300 acre feet a year of sustainable production from the Epworth Gravels. So we need to start looking at minimum thresholds and relating these water levels to minimum thresholds, and we're looking at potential ranges here of water levels in the future, and they have to be ranges of water levels that stabilize. We can't have ongoing declines. So here for the Epworth Gravels, this minimum threshold is actually selected below the lowermost elevation in the higher pumping scenario, this green scenario here. But it's a reasonable estimate, and if we look historically, we have had water levels that have been a little bit lower than that, but we also know that wells in the Epworth Gravels have had to be abandoned, and people have had to drill deeper wells to get to the Fox Canyon Aquifer in this particular area. So currently, as water levels recovered, because people were resting that aquifer, and then with additional production, water levels have declined again. So we're looking within the historical range for the Epworth Gravels. As we look here, it's a similar story farther away from the arroyo, where the proposed minimum threshold is, I think, 120 acre feet per year, 120 feet mean sea level, above mean sea level here. That's the proposed minimum threshold. It's below the water levels that were simulated in these two runs, right at the low end of those. It would allow for some operational flexibility, but we can't have long-term declines at higher production rates. And last but not least, we've got a minimum threshold closer to the arroyo. Again, that's within the historical level. This rise has really been generated by the recharge along the arroyo, And so this would allow for some water level decline into the future, but not an indefinite water level decline. Just as in Oxnard, we related the minimum thresholds to the 2015 water levels. If we look here, this is the West Las Posas Basin. This is minus 60 here, minus 80 here. At this 16J03, I think that was there was an error in the initial memo, for which I apologize. It was corrected at the board meeting, and hopefully it's been corrected in the packet that you have. So this is a revised minimum threshold for that, minus 75 feet. It's right in this range of the 2015 water levels. Farther east in the basin, minus 150, minus 150. Those are actually, again, in a very similar range to the 2015 water levels in the eastern part of the West Las Posas management area. If we look at the East Las Posas management area, these water levels are, the minimum threshold water levels are below the 2015 water levels and would be allowed to decline somewhat. Water levels from 2015 would be allowed to decline somewhat moving into the future as planning is implemented to get the water levels to stabilize. There's also a question when it comes to chronic water level declines of what this would mean to an individual's well and what the water level elevation for minimum threshold, how you would relate that to a well screen. We do not have all of the information on well screens and where a pump is set in the well, because that's going to impact your ability to maintain production at a given minimum threshold. But I want to keep in mind, the minimum thresholds do not directly apply to an individual's well, right? So if you have a minimum threshold at a key well nearby, it's not directly related to a water level in your well. But we did attempt to look at where we knew information about well screens and what that meant relative to the Fox Canyon aquifer surface. So the contours in this map are not water level contours. They are the surface contours of the Fox Canyon aquifer. You can think of it like looking at a topo map, right? When you're looking at a normal topography map, you see that there are mountains and valleys. Well, the Fox Canyon aquifer has been folded and faulted, and it has depressions and rises in it. And so that's what this contour map shows us. And I'm not going to dwell on this, but basically we're seeing relatively good agreement in the colors. The colors are related to the dots, or the individual diamonds and circles here. Those colors are the well screen top, and the colors of the contours are the colors of the Fox Canyon aquifer. But when we actually look in a little more detail for the wells for which we do have information, so we can look at what we know about well screens and make some very broad generalizations about what we would estimate the minimum threshold would look like in a well, a kind of a zone of influence around an individual key well. If we look at active wells screened solely in the Fox Canyon aquifer, there are 61 of them for which we also have well screen information, top of well screen. And in those wells, if we assign a sphere of influence around the key well, and we just say that that's the water level for all of the wells in its sphere of influence, for 90% of them, the minimum threshold is more than 50 feet above the top of the well screen. That's accounting, again, we don't know where all the pumps are set, so that's trying to account for a pump being set above the top of the well screen. In 8% of them, it is not more than 50 feet above the top of the well screen, but it is above the historical low water level. And in one well, that's what this 2% is here, in one well, the minimum threshold is actually below the historical water level. If we expand this to looking at wells that are screened in multiple aquifers, including the Fox Canyon aquifer, but do not have a well screen that starts above the top of the Fox Canyon aquifer, so Fox Canyon and below effectively. There are 80 wells for which we have information on well screens, active wells. The minimum threshold is more than 50 feet above the top of the screen in 85% of those wells. And it's a little bit more complicated here because I don't have historical water levels for a lot of the additional wells that got added into this group. And so instead of doing the exact same thing here, I just said, okay, is the minimum threshold above 20 feet? So is it 20 to 50 feet above the top of the well screen? That's 6 of them. And then there are 6% of them. And in 9%, the minimum threshold is within the well screen interval. I don't have the historical water level for a lot of those to be able to tell you whether or not historically they've been that low before. So keeping in mind here, the minimum thresholds, again, they're meant to be static water levels. They're meant to be measured in key wells, not for every well. So this is the same slide we saw for Oxnard. And they are meant to be a measure of basin-wide conditions and the water level response in the aquifers to the collective groundwater production of the basin. And this ties back in to something I should have said in this slide, which is that this is where we're starting to get into the understanding of what's significant and unreasonable, and this is ultimately a board decision to look at. When we look at these minimum thresholds, they are based on basin-wide undesirable results. And so that's what we're looking at here. We're looking for basin-wide undesirable results and what is significant on a basin-wide basis. Lastly, in East Las Posas, when we move to talking about the measurable objective, it's not as simple as it is in Oxnard, and I'm not trying to say that the Oxnard case is simple. That was a poor choice of words. It's not as tied to the minimum threshold is what I really should say. So in Oxnard, you have to have a tie between the measurable objective and the minimum threshold in order to ensure that you get that seawater intrusion to net to zero over time. That's not the case when you're looking at water levels that don't respond particularly rapidly or particularly in any particular major way to climate cycles. So instead, we do see that there is some response to climate here, and there's some response to climate here, with increased rainfall leading to increased water levels and periods of drought leading to decreased water levels. There's not a strong climate response in the way that we see in other basins. And so as a starting point, we selected, in fact, the median water level for the higher of the two scenarios that were sustainable. This will certainly be reviewed. We certainly welcome feedback tonight on this. And it's a starting point for the measurable objective. So in this well, the example would be 240 feet above mean sea level. The minimum threshold was down here below 200 feet. These will be reevaluated as we understand which projects will actually be implemented. And in this basin, water levels are really so dependent on the projects that are implemented or the ability to maintain recharge along the arroyo. And so we need to understand how much recharge can be maintained in order to really come to a measurable objective. And so that'll continue to be evaluated moving into the future, which brings me to what is the path forward here. Looking backward before we look forward, we see that ongoing production at the 2015 to 2017 rates is not sustainable in Oxnard, Pleasant Valley, or the Las Posas Valley Basin. There were reductions in groundwater production that we implemented in consultation with TAG and staff in the model runs. And those reductions were implemented as a linear ramp down over the first 20 years. So there was a linear ramp down to a sustainable rate, and that sustainable rate was maintained through the last 30 years of the simulation. That is because the basins are required to be sustainable by 2040. So between 2020 and 2040, groundwater elevations can be below the minimum threshold. And in fact, in many cases in Oxnard, we see they will be below the minimum threshold until we bring them up. And that is the period between 2020 and 2040 when basins are working toward sustainability. The actual path and the long-term production rates will depend on which projects are implemented, the location of the pumping, climate. We know that we picked a 50-year climate period. That's not going to be the exact climate period that happens. And other uncertainties, I should have said, rather than unknowns. Here we have a historical water level that is currently below the proposed minimum threshold. With time, it will need to go above the minimum threshold, and in fact, with time, it'll need to eventually go above the measurable objective. But there are many paths in this gray area here to get there. So the nuts and bolts of the path forward, the draft GSPs are going to be prepared. They'll be coming out later this year. They will provide additional context for everything I said tonight, and hopefully you'll clarify with, you'll ask any clarifying questions. I'm sure I misspoke tonight. They will provide additional supporting documentation. Those drafts will be released by the board for public review. That's currently envisioned as another 60-day comment period, similar to the preliminary draft GSPs. And during that time period, there will be an additional stakeholder workshop. And the comments collected during that time period will be integrated into the final GSP. And I can't emphasize enough, what we've come to is the starting point. This is where the process really begins of planning towards getting towards sustainability. Because as part of SGMA, the Fox Canyon Groundwater Management Agency is required by the state. It's not an optional thing. They are required every 5 years to reevaluate the GSP. It's not a voluntary action. And over the next 5 years, there's going to be a lot of work done as people start to see where the estimates of sustainable yield have gotten us so far. There's going to be a lot of work done to improve those estimates and to increase the yield of these basins. As additional data are collected, the sustainable yield, minimum thresholds, and measurable objectives are expected to change through time. That's how we improve our understanding, and we adjust and we do adaptive management. And the basin management needs to be optimized. So it's going to require projects that haven't yet been incorporated through the process. It's going to require looking at potential for changing groundwater production. And as that groundwater production areas shift, that may require lowering the minimum thresholds in some areas or raising it in other areas. And looking at additional projects, again, a lot of projects here. And with that, I am happy to take questions. This is the website for where you can look at the full memos. And I think on the same websites where we've got the preliminary draft GSPs and yeah.
So, well, I raised in here. We ran a little bit late on the board meeting, and so I neglected to do some introductions. And for those who don't know me, I'm Kim Loeb with Fox Canyon Groundwater Management Agency. We do have many of our directors here today. We've got Chair Gene West, Director Ranio, Director Borchert, Alternate Director Perillo, and Director Bennett couldn't make it, but he said that he was going to watch the recording of this. And so this is being recorded for those, if you have no other stakeholders who aren't here today, this workshop is being recorded, and these slides will be up on the website early next week. We'll get those up on the website. And so then we also have our DUDEC consulting team that's preparing the groundwater sustainability plans for us. You've met Jill Weinberger already. We've got Ron Schnabel and Peter Quinlan here as well. And so we'll open it up to questions. And we do ask that you use the mic so that way it does get recorded for those who are either watching the live stream or want to see the recording. They'll hear the question and be able to hear the answer as well. Thanks. Questions? We're ready. So you can either use this or either way you want to go.
Since the board's not up there, maybe this one. Steve Bachman, I'm on the technical advisory group. I wrote a memo to the board and to TAG a month and a half ago or so. Got a 6-page response from the consultants. I appreciate that. We agree on some things and we disagree on other things. There are 2 things I'd like to just comment on. I have more comments, but kind of 2 big issues. One of them on the coastal area with seawater intrusion. The other one's back in the more inland areas, such as East Las Posas management area, where the criteria are for chronic lowering of groundwater elevations. So the coastal one, the peer review of the model, when they looked at the sustainable yields, said that they thought that it was a plus or minus more than 9,000 acre feet a year on the sustainable yield. So roughly a 20,000 acre foot swing between the low end and the high end. And I think that, all of us, including the board, kind of has to decide philosophically how we approach this with that kind of a swing. Do you take the high end of that one and say, okay, maybe we're not reducing it enough, but it has the least economic impact? And do we then revisit that? Of course, we revisit every 5 years and see how that's coming. The other one is to be completely conservative, go to the low end of that, in other words, 9,000 some less than what was presented here. And the chances of having any kind of undesirable results are better, of course. You're less likely. But the economic impact is extremely high. Millions, tens of millions, I don't know, maybe even hundreds of millions of dollars worth of projects and things to be able to get there. So I think philosophically we have to all kind of think which approach we want to take on that one. So that's kind of my coastal one. The inland one, and this is a disagreement that I had with the consultants, I said that the typical way one goes about looking at things like what are now called minimum thresholds would be to look and see historically whether or not you had undesirable results. And you had real data to do that. You have real groundwater elevations to do that. And then set your criteria using those. And then circle back and use the models to determine what kind of projects you needed. Well, number one, are you sustainable? Can you meet those? If not, what kind of projects do you need to add to that to get down, to get it so you're meeting the criteria? I think this was done backwards, and we'll argue about this a lot, I think, because I think we went right to the model, and this presentation today just showed it very clearly. These lines are being drawn by model results, not by things that we've measured on the ground that have gone wrong and had undesirable results. So I think we've done it the wrong way. So what happens is that when you come to a place like East Las Posas is kind of an odd basin for a coastal basin because it's not climatically controlled. I think everybody realizes that. In the review, the peer review that was also brought up, what's happened is that we had groundwater elevations that were pre-1990, 1980 that were much lower than they are today. We have put a lot of water in storage in that basin because of all the artificial water that's been coming in because of wastewater treatment plants, dewatering projects in Simi Valley. So we have a lot of storage built up. Now, when those are reduced, when those inputs are reduced, we're going to have those water levels go back down again. Are we trying to keep artificially some high water level in there? Is that what we mean by not having, chronic lowering of groundwater elevations? I don't think that's what we mean. It was mentioned that what DWR talks about is they want to be sure that when you go down into a drought, you can come back out the other side again. Well, that's not the East Las Posas. We don't see that climatic signature. So what we're doing instead is looking at this artificial storage in there, making our rules based on that, rather than allowing water levels to come back down to what they were historically. They come down pretty slowly, and they come down pretty slowly for one really good reason, because some of that recharge is going very slowly through the San Pedro formation. We don't know how long, but perhaps tens of years before that recharge gets into the aquifer. So we have this long delay time, and we're going to expect a very long drop in what the groundwater elevations are. I think with that in mind, we have to rethink what we're talking about here with chronic lowering of groundwater elevations, because we need to say, okay, if we are going back to what we saw before this artificial rise in groundwater elevations, did we have undesirable results? Well, there aren't any documented. I think that's where the place to start is, right there, and let's see if that's the case. Otherwise, this quote-unquote chronic lowering of groundwater elevation and removal of storage is all artificial. And we just have to really remember that when we're looking at it. So I don't think we follow the normal rules here of what we would do on a basin where we're seeing water levels go up and down climatically. So that was a long thing. I'm sorry, but I had to get that off my chest.
Yeah. No, go ahead.
There's a lot there, so I'll just tackle one point. You'd mentioned that historically we didn't see any undesirable results away from the coast, and I think I disagree with that in that you can't measure seawater intrusion directly. I mean, you cannot see it coming in, and we did need to use the model to estimate that. So historically, we've always had seawater intrusion. And to say that those water levels didn't cause undesirable effects historically, I don't think is accurate.
I wasn't talking about the coast. I was talking about...
You were talking about East Las Posas. So I think the one thing is the estimated sustainable yield was about 20,000 acre feet is what we presented. The historical pumping rate, if you look at the whole record, is around 17 to 18,000 acre feet. The recent period, it was closer to 27,000. So the pumping rate, I mean, where it levels off, I guess is subject to some debate, but the production is pretty similar and higher than the long-term historical.
For the record, I'm Neil McGuire, and I know it's been tried to be answered, but I'm going to echo what Dr. Bachman mentioned, but for a little bit from the legal perspective, because with regard to the East Las Posas in particular and the eastern portion of the West Las Posas and the chronic groundwater lowering, I think what we saw here tonight was an attempt to address the comment that was raised at the board a couple board meetings ago on the need to look at the undesirable results. And we do that because the chronic lowering of groundwater by itself is not an undesirable result. When you look at Sigma, when you look at the Sigma regulations, and as Mr. Bondi pointed out at the board meeting, when you look at DWR's interpretation of those regulations, all of them say you look at whether or not that chronic groundwater level lowering leads to undesirable results. And what you've done here tonight is you've picked out one of the other sustainability criteria and said, well, we're going to look at the loss of storage. That's going to be the undesirable result. But that's just the same side, the opposite side of the same coin. Obviously, those two are directly related to each other. And again, when you look at the SGMA regulations, when you are also looking at the loss of storage, that regulation also says that the loss of storage is not by itself an undesirable result, that the loss of storage becomes an issue when it, quote, may lead to undesirable results. So the next step that I think you took here today was to say, well, we're going to look at well impacts, right? That's going to be the undesirable result. I mean, you kind of went phase through, and the last one was, well, we're going to look at, well, people might have to re-drill their wells, lower their wells, and so on. And maybe at the end of this process, the stakeholders in the Las Posas Basin will ask Fox Canyon and the board to say, you know what, that matters enough to us where we would like you to look at those issues in terms of where you're going to set your minimum thresholds and objectives. But that's not what SGMA says, right? And so we still need to go through the process, like Dr. Bachman said, of actually figuring out where we are going to have actual undesirable results in the Las Posas Basin. Where are we going to have subsidence, right? Those are the four criteria. Those are what we have to look at. Maybe we end up setting measurable objectives higher than that, but we got to at least know where those levels are. And as Dr. Bachman mentioned, we've seen a lot lower groundwater levels in that basin, and there wasn't anything on record, not seawater intrusion, right? We saw lower groundwater levels. We didn't have reports of subsidence and so on. That's what I think Dr. Bachman was referring to. We have to find out at what groundwater levels will we see those types of undesirable results. Again, maybe the measurable objectives and thresholds get set somewhere else, but we should know that information. SGMA tells us we have to find out that information. So the other point, excuse me, oh, I just hit a button here. I apologize. Some of the graphs that we were presented with regard to the measurable objectives, they show your yellow lines and your purple lines above the minimum thresholds. And then above that, above both of the yellow and the purple scenarios, you have your measurable objective. And as far out as we project, we never hit those measurable objectives. There are a number of wells where that's what those graphs show, that under any scenario, reduction in pumping with projects, without projects, we will never hit those measurable objectives. I'm having a hard time understanding why we would set our objectives in a location where we know that we're never going to hit them. I would assume that DWR would look at that and say, well, you're never going to get to sustainability long term with those measurable objectives. So I would encourage you to look at those wells. I think there were probably about half a dozen of them where they would never be satisfied. And so obviously those objectives, we will have to have something that's actually going to be achievable. The last comment that I'll make is with regard to the western portion of the West Las Posas Basin. And again, this mimics a comment that I've made in the past up here before the board, which is in terms of setting the minimum thresholds and the minimum objectives and looking at yield, the scenarios that have been run have all included uniform reductions in pumping, 20%, 25%. Just to be clear, I am not asking for a scenario to be run that would ask the Oxnard Basin to reduce their pumping even further. But it is important to run scenarios that tell you whether the inland areas in PV and the West Las Posas can reduce their pumping at a non-uniform level and still have the same result with regard to limiting seawater intrusion. So instead of a uniform 20% cut, is it 20% by the coast and 18 in PV? Is it 25 and 23, somewhere along those lines? So I think that would be important to know, and that's my last comment. Thank you.
And just to address your last comment, the scenario. To address your last comment, the scenarios did do that. the reductions in PV were, in Oxnard were greater than they were in either PV or in West Las Posas. And we also looked, in one of the scenarios, looks at no reduction in West Las Posas or PV and the impact on the seawater intrusion at a larger reduction in Oxnard. So I think we have done that. We have made not uniform, but simulated differential reductions by basin. And in terms of the measurable objective, yeah, we should review that. I mean, the intent was, as we showed in the one we did have here, was that it would be the median water level. So if the measurable objective is above all the simulated water levels, then it should be lower.
Any other comments or questions?
Hi, my name's Brian Bondi. I'm on the tag. Excuse me, losing my voice. I just wanted to echo Dr. Bachman's comments. I've been pretty vocal on this idea that we need to identify and define significant unreasonable effects and the relationship with undesirable results as the basis for establishing the thresholds. I think the regulations are pretty clear on that. I just want to note that Dr. Bachman talked about the East Las Posas and the water that's come in along the Arroyo. The central and northern part of the basin has not seen that benefit, so the comments about prior historical lows don't really apply in every area, as do they not apply in the eastern part of the West Las Posas. So it's important to understand when you're developing your representative monitoring sites and your thresholds and objectives that you understand how the basin's reacting in those different areas so that we manage all the different parts of the basins according to what's actually happening in those areas. Thank you.
Any other comments or questions?
Hi, Martin Gramco. Maybe you can help me understand the difference, how you get to the minimum thresholds along the coast. I understood the measurable objective concept where in your long-term plan you have some years where water's going offshore and some years coming in, and so there's kind of a net zero. What I took from the the threshold was that you kind of you ran your model, you saw the variability, and we set the threshold kind of at the bottom. Is that where that you kind of backed into the threshold like that? Is it kind of close?
Some cases below the bottom.
Yeah, that's effectively what we did.
Okay. So then, if that's the case, then when you ran the model, we would have, we had wet years and dry years in your climate. We would have impacts to pumping during those. And did you allocate, essentially we would have reduced pumping during wet years. And so what we would see is probably even more dramatic and a kind of a deeper, we may want to push the threshold down because you would, see when you get a kind of a broader band.
Yeah, I think that's, Peter's the modeling expert. You're absolutely right. This simulated a constant production rate as the starting point for developing these. It gets far more complex as we move forward, trying to simulate the actual production rate tied to climate. The variability that you did see was primarily related to the ability of United to spread water in the spreading basins and deliver water through the pipeline systems. So some of that was accounted for in the model. But we have not yet taken the next step of varying pumping as dry years require additional pumping and wet years people can rest their wells. And I'll let Peter say more.
Yeah, I think you're absolutely right, and I think that's something that we would go into in the next 5 years to try to set the the initial estimate based on these constant rate. In fact, these simulations showed, because the reduction occurred in the first 20 years, which happened to be wetter than the next 20 years, the pumping is higher in wet years than it is in dry years. So it's, to that extent, it's unrealistic, and the measuring minimum thresholds could be, may be adjusted lower as we move forward in the next 5 years and, simulate the pumping that's matching
the
wet
climate.
and dry years. Yeah, and the other thing, another reason why it's probably reasonable to just start with where we are is that hopefully in the next 5 years, the community comes forward with projects that allow the shifting of pumping more, that would allow increasing yield from Oxnard.
Yeah, which was my next question. So what I understood from the presentations is that you applied differences in reduction by basin, but they were linear or essentially uniform within the basin. But we haven't, say, looked at Oxnard and said, done what some of the work it's done at United, where we said, well, let's move some pumping within that basin around.
Yeah, so we were constrained by the projects that met the Sigma requirements and were put forward by the board's operation committee. And in that there was, and so in one of the projects, or the projects include the delivery of reclaimed water or recycled water, whatever the current term is, from the Oxnard Great program to the coastal area to reduce pumping there. And so that's why you think you see in those simulations there is less seawater intrusion than there is in the other that has more reductions. And we did differential cutbacks in the upper system from the lower system. In addition, there's the fallowing was one of the projects brought forward. So you don't see that in these yield numbers, but that project entails paying to not pump. Right. And that was 500 acre feet in Oxnard and 2,000 acre feet in Pleasant Valley. And we applied that to the extent that we could in the lower aquifer near the coast. It was complicated by contract deliveries with United through the PTP and the PV pipelines. So that gets into a whole level of detail that we couldn't work out at this stage, but could be worked out in the next 5 years.
So just one more thing, Kim. So as a member of the pumping community and ultimately the community that would fund these projects, it would be useful for the technical community to say, look, guys, you need to pump here and not pump here. And get kind of more specific for us so that we can think about how to solve that. That would be, just kind of my recommendation.
So I just wanted to follow on that a little bit. It got touched on, and Jill talked about it in her talk, but it's really important to keep in mind that the GSPs, the groundwater sustainability plans, they have to be reviewed and updated on a minimum of a 5-year basis. So this is not a plan that is going to go on the shelf and be written in stone forever. We have a lot of work to do once the plan's completed. These are based on the information we have now and the scenarios that we're able to model with the projects that have enough feasibility information included in it. We know this is not what we're going to look like 20 years from now. There's a lot of work to be done studying all these other opportunities and ways that we can optimize the management of the basins over time as we have this 20 years to get to sustainability. And so this is a starting point. It's not the end point. And so I think that's important to keep in mind. So I just wanted to make sure that was clear to folks. So I think I saw Jane.
Jane Waters. I'm a grower in the East Las Posas and on the Burlwood Mutual Water Company board. And I did one of Burlwood's wells is a key well, and it looks like when we take Burlwood data that we get every year or whatever from our pump efficiency testing, that those water levels are not necessarily consistent with the water levels that are shown with the data that's on the charts that we were given. So my question is twofold, I guess. Where does that data come from? Because it doesn't come from the owner of the well. And then secondly, if there are discrepancies, how will those be reconciled? What kind of process might there be to reconcile differences?
I'm going to start this and hand it off to Kim. So you're talking about the historical water levels that are shown on the hydrograph?
Yes. Yes.
Okay, well, I'm handing that off to Kim because the agency collects those.
So the water level information comes to the Watershed Protection District. They collect all that information. It's reported to others, and that's where that information came from. So let me follow up with you on that. I don't know the answer to that question. I think that's probably an exception there, but we'll follow up and find out. But the water level data that Dudek was using was the information that's reported to the county by the county measures throughout, and then also other agencies measure and report to the county.
Right. And I guess my bigger question is, there needs to be a procedure to, going forward, reconcile those differences. And I don't know what that'll be, and obviously there's a way to work it out, but.
Okay, thanks.
Thanks.
Hi, my name is Alma Quezada, General Manager for Zone Mutual Water Company. I took a look at the key wells that you chose for the Las Posas Basin. It looks like there's a total of 22. One of the wells that you chose is one of Zone's wells, the one ending in 07R02, and it's a key well. So that is a well that Zone destroyed in December of 2016. So you might want to choose a different key well.
Yep.
Thank you for that comment. That was actually very helpful. Is this on? We are working with the data set that we have. I think that runs through close to the end of 2016. So updates like that are useful for us. I appreciate that. Thank you. Yes.
Yeah. So we'll follow up with you on that, Alma, and thanks for that. I mean, that is an ongoing challenge. That has been a challenge where you have these wells with long-term records, which are great, but then they get destroyed for operational reasons. Anybody else, comment or question?
Our row's very vocal. I'm Lori Cravioto, and I'm a grower, and I sit on a board of Fuller Falls Mutual Water Company. And I guess the thing that disturbs me, and I'm echoing, again, Dr. Bachman a little bit, but I just feel like the minimum threshold for Las Posas, I'm not feeling very much confidence in it. And I wonder, how do we get to a point where we could feel confident that, I get that we don't want the groundwater going down over time or losing a lot of storage. So I get all that. I just don't feel that with the historical number here and then the Arroyo Grande recharge going away, how can you help us to feel more comfortable with this minimum threshold? Does anybody else feel that way?
I'm not sure I can answer your question or really reassure you to a degree that you would welcome. I think the key for us really has been to look at what groundwater production rates are sustainable over the long run, because that's, in this case, it's unfortunate that that can't be reported to DWR as proof of sustainability, but it can't. And so we've gone through quite a bit, both in looking at the historical water levels and in looking at what the modeling results would suggest for long-term sustainable rates, and that's how we came to the minimum thresholds. If we, and we've only done a little bit of this, and so I can't give you precise numbers, but if you look at, say, the baseline production rate, which I think everybody looks at in East Las Posas and says, okay, this water level's dropping throughout the basin, and it's greatly tied to recharge in the arroyo as well as production. But if you look at that rate, the difference in the water level between the minimum threshold where we currently have it selected and the baseline predicted water level in 2040 at the period when you'd have to start being sustainable, it's on the order of 20 feet. It's not large. And so we have other things we need to develop, and those would be the kinds of things and the additional context that would be provided in the GSP. I don't know if that answers your question, but we have looked at this from multiple perspectives, and we're open to suggestions from stakeholders of adjusting those minimum thresholds for specific reasons. That's why we're here tonight. So if you have those suggestions, we certainly welcome them.
First of all, thank you. My name is Anthony Brown. My questions may reflect more on my ignorance than perhaps any criticism of the presentation, but the first question relates to some things I heard during the presentation, and even afterwards. Kim was referring just a moment ago about the fact there's still a lot of study needs to be done and data collected to address all sorts of uncertainties. I also heard during the presentation that the sustainable yield is going to be highly a function of the projects that are implemented, but those projects have not yet been defined. Given that the projects haven't been defined, given there's a lot of uncertainty, I'd ask, is it reasonable to then perhaps recommend any pumping reductions, particularly any pumping reductions starting in 2020, given the likely economic impact of those reductions, before such projects are defined and the studies are complete?
So that's a policy decision which the board will work with in terms of looking at the path to get to sustainable management of the basins in the 20-year period, and how we get there. It's something they have been discussing, but they're waiting till the groundwater sustainability plans are finished, and we have the baseline for mapping the path to get there. And one of the things that Dudek and staff and others have been laying out is the uncertainty that we have right now and the data gaps in which go into informing the board to make the appropriate policy decision on how to start moving towards the sustainable management.
Then my next question. Obviously, we understand that for 3 of the management areas, saline intrusion is considered the most significant undesirable result. And that, as some of the presentation we saw today, obviously was some of the modeling results for projections of saline intrusion. And again, this really does, you're educating me by answering this. The modeling, is that actually including the saline intrusion package within the model, or is it just particle tracking?
It was just particle tracking. So the way the model reflected the density of seawater by having increased head at the general head boundaries to reflect the hydrostatic column of water in the ocean. So when we talk about seawater intrusion and the volumes, we're talking about the flux through the boundary. Beyond that, when we talked about the migration, those were just particle tracks. And so that does not mean that the chloride concentration of 500 migrates that far. You know, obviously there's mixing, there's diffusion into the pores. So it doesn't mean that the 500 milligram per liter front would move as far as is shown by those particle tracks.
So given that that is the critical undesirable result, would it not be advisable, for the management agency to upgrade the model with a complete saline intrusion package so we would actually have concentrations that we'd be able to track of chloride?
That's certainly, something that could be done in the future. I think that would be a reasonable thing to do.
Yeah, I think given that we're making management decisions for groundwater use based on the potential for seawater intrusion, that would seem to be an important thing to conclude.
Well, I think the model adequately addresses the potential for seawater intrusion. The question you're morphing that into is, what is the concentration some distance from the coast? And, it does, address the density difference through the adjusted heads. So I believe that it does accurately reflect, within the uncertainty that we've described, the flux in. And that seawater as it comes in, whether it's offshore, is also a loss in storage because it's changing, the quality of the water. So I think in terms of the initial estimate, I think we have a good tool and we're in a good place to come up with the initial estimate to make very gradual changes and do additional studies and perhaps look at the and try to calibrate a solute model to chloride with sparse data.
Then last question. Has there been any modeling effort to look at how much fresh water would have to be injected or brackish water pumped or a combination of the two to just completely mitigate seawater intrusion?
Not as a part of the GSP development. That was not a project that, rose to the level of being able to be included because there's no project proponent. I can't speak for United, whether United has done that. I know they have looked at a variety of things to try to mitigate this. We could only do what we could do by a management action. We only simulated what, a management action with sort of a uniform reduction by aquifer zone or basin and a project that came forward. So that's not a project that came forward.
So again, back to what I was mentioning before is once we have a deadline to get our groundwater sustainability plans in, they will be revised at least every 5 years. That's mandated, and they can be revised more often than that. There's a lot of work to be done once these first groundwater sustainability plans are done, and looking at regional solutions, projects that could be envisioned and develop feasibility analyses and funding mechanisms to implement for the stakeholders and the board to consider is all work that that will be undertaken moving forward. So it's not that they're not being considered, it's that this is a starting place. This gives us a good starting place to begin a lot of that work. This is a process. It's not a destination. And so there are a lot of conceptual ideas out there that will have to be looked at, modeled, and feasibility analyses conducted in the future once the GSP is done to see how we can optimize the management of the basin down the road. Other questions, comments? Brian? I don't.
Brian Bonney again, this time with my Kyagas hat on. It dawned on me as I went through the graphs that it looks like a number of the wells are including pumping groundwater levels, particularly those wells where you've plotted transducer data. So if you're in some cases, trying to establish minimum thresholds based on historical levels, particularly lows. We need to make sure that we're plotting static water levels. And the reason this jumped out in particular is I realized with the latest memo that one of the wells for the East Las Posas is actually an ASR well. And I'm not here today to offer an opinion about whether that's right or wrong, but I think that that's something that should be carefully thought about because of the injection and storage and recovery activities certainly cause fluctuations in levels that are perhaps not representative of the background conditions in the basin. So that needs to be at a minimum understood. Thank you.
Brian, I'm sorry if I could, I want to understand what you said. So you're saying you think it reflects from the transducer data a pumping water level from within that well, not a water level in that well that reflects pumping adjacent to it?
Are you asking about the first part of my comment?
Yes.
It just appears to me that what you've plotted includes pumping water levels, which we should not be making thresholds and objectives off of pumping levels. We should be making them off of static levels. And so the comment is just to please go back through the data and make sure you're not plotting pumping levels and using that as a basis for setting thresholds and objectives. So it needs to be consistent, and the only way to be consistent is to look at static groundwater levels in the wells we're evaluating.
We agree with that statement. We're not using pumping water levels. They were plotted on some of the hydrographs that came out to give a sense of what the variability in a given well, but they're not being used to determine the minimum thresholds. The pumping water levels are not being used to determine the minimum thresholds.
Okay, well, you've heard a lot of comments today about going back and looking at historical low groundwater levels and considering whether those should be used to establish thresholds. So I guess the comment applies to that exercise, if that's an exercise that's going to be undertaken.
We are certainly aware of the difference between the pumping and the static levels, and that the need for the minimum thresholds be set at a static level.
Any other comments or questions?
Susan Mulligan, Cayugas Municipal Water District. I was curious, you looked at the wells and how many had water levels that went below 50 feet above the top of the aquifer. I was curious how you came up with the 50-foot number.
I think this is on again. It's an estimate, right? So it's, excuse me for 1 second. Didn't want to do that into the microphone. It's a number that we came up with to look at whether or not you could have pump bowls set above a well screen, right? To account for the fact that pumps aren't set within the well screen itself.
Did it consider drawdown? Is that what you expect drawdown would be, 50 feet?
We don't have the data for every single well. We don't have the pump levels where they're set. We don't have the tests from the wells to know exactly what the drawdown is going to be in the wells. It was a water level that was selected to be indicative of being protective of a pump that's set above the top of the screen. We can give you other statistics on higher water levels if you would like to see what it would mean for other higher water levels, but I don't see a reason without additional data to change that at this time.
Okay, it just seemed like maybe water levels and typical elevation above pumps for required section head would be reasonable, and some of that is probably determinable.
Certainly. Thanks. Anybody else? All right, well, not seeing any other questions. Thank you all for your attendance here for spending the Friday evening with us. Enjoy your weekend. Again, this will be up, the slides will be up on the website. The materials are on the website, and as well as memos explaining the modeling and methodology. Good night.
question for you.
The problem, there's a consequence to not doing what we need you to do, which is to tell us where to pump and not to pump, so that we can have some, essentially a smoother glide path. That's the consequences. When Kim says, oh yeah, we'll get there, the rest of us are like, you know, sliding down the ski part of the ski slope, and we're beginners.
I appreciate your comments. I understand your perspective on it.
Well,
Right.
I don't know that that would be that far. I think that would be within the mountains.
By the board.
They would have to come to us and say,
Then we can